Welcome to SystemVerilog course, and in this course we will cover everything from data type to writing code as well as writing protocols. Everything we will cover similar to our Verilog course, but in SystemVerilog we will go advanced than our Verilog because SystemVerilog are mostly used and most powerful language in our VLSI. Okay, so let's start without any delay. Data types in SystemVerilog. So data types are mostly storage format for specific range is called data type. This is true mostly for our coding languages, okay, like C, C++, okay. But in hardware we have two types. First is net type and second is this variable type or storage type. So we will say variable type. So in net type you have already studied wire, and in variable type you have already studied range in Verilog. So wire is driving type of data type and range is storing type of data type. Okay, so these two data types are 4-state, but we don't have 2-state data type in our Verilog. So here SystemVerilog has given us 2-state of data type, and it will have 0 and 1, and we already have 4-state of data type in Verilog, so we are following that as well. So we have both 2-state and 4-state. So 2-state, what does mean 2-state of data type? So it will only have two values, 0 and 1, and in 4-state data type we have 4 values, 0, 1, x and z. So as per the use we are using both, and we have our wire and range in SystemVerilog as well. Let's move forward. So here is another concept of signed and unsigned. So what does signed and unsigned mean? So unsigned means can hold positive values. So you have already seen this unsigned type. Okay, for example, if it is 3-bit data type, means it will store up till 0 to 8 this number of values. So decimal values 0 to 8 decimal numbers it can store if it is 3-bit. Okay, but if it is unsigned data type, so it can hold positive and negative as well. Okay, so it will store from -3 to +3. Now how? So if you are storing 3, it will be like 0, 1, 1, right? So if you are storing 3 in unsigned data type, it will be 3. This value will be 3. But in signed, if it is 0, if here it is 0 first number, then it is positive 3, and if it is 1, then it will be negative 3. So in this way, this first bit can show you it is positive number or it is negative number. So we have our signed and unsigned data type. Now literals. What does this literal mean? So fixed value in program is called literal. In short term it known as constant. Its value can be altered using execution of program. So nothing, it is called parameter. Okay, this is example parameter. You already seen in Verilog. Now variables is like your range. Variables you have already studied, that is our range type of data type. Range, int, bit, whatever you can make a variable. Okay, so variable is very common topic and common knowledge for everyone who are studying coding, so I will not focus on variable that much. So constant, we also have a const keyword in our SystemVerilog. For example, p is equal to 3.14. For example, you have given pi value, so this will remain same for all throughout the program and you cannot change it, and this will be considered as constant. Okay,
hit subscribe, like and comment now. Let's begin the journey of verification.
so let's move forward and learn about how many data types we have in our SystemVerilog. So first is int, and you know about int in your coding language. The same int is used here, 2-state. Now integer is redefined, it is 4-state. So similar to int but having x and z as well. Short int, long int, only here is change and it is similar to your int. Okay, not integer is 4-state. Okay, now bit is 0, 1, 2-state data type. Okay, and unsigned data type means these 3 are signed, 4 are signed data type, means you can have your first bit, this one first bit as your signed or unsigned type. Okay, but in unsigned data type we don't, and bit also have doesn't have any range. Okay, it's not dependent on 32-bit, 16-bit or anything. You can specify your range as a vector, and you have unsigned, so you have only positive value here. Okay, now byte we don't use this that much, and logic I will explain in our last topic is our logic, and the very thing difference in our system Verilog and Verilog is this logic, so I will tell you after this one. And range you already know, time you already know. Okay, now real, short real and real time data types. So real data type means you can store your fraction like 0.0, 0.1, so this type of thing you can store in real, and similar to this real is short real, only range is little bit less. And real time means you can use time for storing the fraction, so you have your time. Okay, so you cannot store this dollar time 0.1, but if you use dollar real time you can store 0.1. so this is our dollar time use, known as real variable. Okay, so real same as double as in C and floating. Okay, so I have already explained you this thing. Now void data type, non-existent data type known as a void data type, it is usually used in function. Okay, so void, you have seen this function void, and you will see this in my upcoming videos in SystemVerilog course. So this void means the return type we used in this function. You don't need to use this return if you use void, so you can use this thing for dollar display. Okay, so this is the thing. And string, it is our array part, so I will explain in array. And string data type, you can store alphabets like A, B, C. I am using here alphabets, but there is some ASCII number, so you can store these things. And also you can store this as our number itself, or constant, or our any name like Anas, if Anas is a name in your string. So this is our string. Next thing is our event. So event is not I consider as a data type, but it is part of data type, you can say. So you can include a data type event E. So this event E is a E variable you can use for setting an event, and you can trigger this event with this, and you can trigger with this and use wait for this. So this variable you have used in my Verilog course, so you can set this keyword E event with E. Okay, now user defined data type. So we use this in SystemVerilog, a very powerful concept SystemVerilog has given us with our user defined data types. So you have to use type def int. So if you use type def, so if int is already given example, so I will use another variable like real, you can say real, and you can say my as this, and so my will be my new data type, and you can use my as data throughout that course or throughout that range. Okay, now we have our enumeration data type. So enumeration is a type of concept used in data type. So what does enumeration mean? So enum is a keyword used in enumeration. Enum is a keyword. So if I write A, B and C, so by default it will take int, so it will say 0, 1, 2. So it is named variable, means A is equal to 0, B equal to 1 and C equal to 2. So if you are using in case A, so it will consider 0. Okay, and then your logic. So mostly we use this for this thing, and you can also set your own numbers like this. So enum, we will also use this in our course, so we will also more focus on this one. Now the most important part is logic data type. So I will explain you what is in this explanation here. So if you know a sign, if you use, so this before our equal to signs mean LHS, it is compulsory to use wire, but in always block, in LHS it is compulsory to use reg. So sometimes it become problem if you want to use both. Okay, so this problem is solved by this logic data type. So it has the functionality of wire as well as it has the functionality of range. So what will be default? Because wire default is Z and range default is X. So it follows range most times, like its default will be X. Okay, but you can also drive in assign, and you can also use in always block. So because of that confusion between range and wire, we use logic. Okay, so it is similar to your range. So in SystemVerilog we mostly use logic data type.
Please Lord give me a sign, a sign.